the proof, right? So now I will show the how we can use really the science for the society, because that part was to just conceptual understanding, but this part will real application. And because in that part was the what is the latest science is going in the worldwide that I discussed, but this part we will discuss about the what kind of the science we discuss where we can say like that it can be directly application for the society. So I will majorly here first I will discuss about the our new area like the fluorescent, which is I spent last 14 years. So first I will discuss about the luminescent material for the security ink, and then I will discuss about the energy material like the hydrogen storage technology for the two-wheeler or three-wheeler. So this way I will completed my topic like the energy conversion as well as the security application. So because security is more important than the we talk about the energy. So first I will prefer for the security, because once you are healthy, wealthy with the mind, then you have to need the energy. If you don't have the security, then energy can't work. So first I will discuss about the. So before that, I can for the youngsters are here. So I will just to tell you a story, very small within a 1 or 2 minutes, because it's very important. When I was doing the studying on the BSc MSc, that time I hate the spectroscopy. Although I get a very good teacher on the spectroscopy, and teacher was Professor D.K. Rai. He was one of the professor. He is the youngest professor in India, 27 years old, and he got the even from the Asia. He is the youngest one. But when he start the teaching, he always said you can just put down the pen and the paper, and whatever you can just listen. So sometimes it's a fundamental to establish. You need to be, in my opinion, to write the things as well as the you yourself the note. Otherwise, just like to listen, it's very difficult. So that time I thought like that. Okay, anyhow, spectroscopy I can just to pass out of 70. If I will get the 20 is okay, 25. Just like to. I never knows to on the day will come, then I have to do the spectroscopy. So, but the conceptual understanding and establishment by the DK was very good. So that time I just to establish those kind of the spectroscopic techniques and selection rules and other things. Because I told whenever you start any subject, it is very important for the to make the your base. So fundamental is very important to any kind of the science, any kind of the technology. So what's happened when I joined to NPL? That time I joined to Fluorescent group, and that time already TV phosphor discovered, and the plasma TV phosphor discovered. People thinking for the luminescent material for the solar cell. So I thought like that something different. So I always believe in out of the box thinking. So I thought I went to some new area, and that can people can realize. So I just to start to see where the fluorescent material used. Many places I seen in Q-Light and other places. But I'm surprised to that time to see also currency there is a chance to explore, but nobody is working. So I thought why not this area can be, and it may be that time it was not much mature my decision, but I thought like that I want to discover something that it cannot be denied by the friend or enemy. So I thought it can be put on the currency, then no one can deny, right? Maybe they don't like to be part of me, but anyhow currency they had need to daily life, right? So that kind of thinking I started this area, and that time when he started the first publication, that time then nanotechnology I submitted, then they said like this is a not worth work, and it is better to you can just to say send some other general. So the fighting spirit in me from the childhood. So I thought to say like that you can show in any search engine, any publication in this direction, I will just remove my article from your submission. So I given all the search engine, all the search. Ultimately, I didn't found, and he agreed to publish. And that was in my 2010, the first paper come in the security ink. And till date, many papers I have and many ideas in that. So this is the story I started this field, because the young guys are very important to understand. So without much taking the time, I can just go for the. So this is the slide where I'd like to focus your mind. I put especially for the, if you see the our Honorable Prime Minister Narendra Modi ji, and nobody can deny to memory regarding when they announced the demonetization. So everybody was the part of the demonetization. Somebody is like some money they cannot able to convert or like this that blah blah. And people, thinking very wrong direction to government, it may be taking right decision, wrong decision. But I can tell you, he's the only prime minister. They have the guts like any field. And I'm surprised to last 80 years, nobody looking in this area, and they look very nicely, and they think like that, because even they done this accidentally. They try to search the black money. Ultimately, whenever money is going to collect, they surprised to see because that same money numbers series, everything was same from the 25 different states, and it was very difficult to see which one is right, which one is wrong. Then he given to the printing agency and said, you can just to tell me which is wrong, which is right. And ultimately what's happened, they cannot also, because the security feature we import from the abroad. Then Prime Minister was thinking like that, okay, 80 years and we are importing all the features from the abroad. And situation like that, we importing these features like we said our neighbors too, you can just put lock in my house and my house would be safe. Then he was totally surprised. And then he making an initiative to RBI, and I will show the video, and he said like that, why not we can do this kind of the synthesis in our India and indigenize these things, because a lot of money is going to invest, and ultimately if you see, there is a chance for the counterfeiting. So why it's counterfeiting happen, how counterfeiting is happen, I will discuss in detail. So mainly I shown in the currency as well as the medicine, but many places this kind of the counterfeiting is going on. Like if you see the coronavirus, that the even vaccine. So if you are not the right security feature tag, then can be also counterfeit. So that is the reason behind the counterfeiting tags are very important. So because counterfeiter can make the duplicate, so that can directly influence to your life. So although I told I have the many areas, and people sometimes very like they feel like that how is working so many areas, and so but you can work any areas because you are working with the material, and only the applications are different. But if you understand the material, if you talk the material, you can realize the material. If you live with the material, you can exploit the material. So that is the idea of to how can exploit this material for the particular area. So already I have different experience, but I will discuss about two things. First, security, other is the hydrogen energy. So before I can start, it is better to you can just listen this video. It's very important how they get the initiative from the Prime Minister.
और इंक भी इंडियन हो, ऐसा नहीं चल। जिस गांधी ने स्वदेशी के लिए इतनी लड़ाई लड़ी, वो विदेशी कागज तो उसकी तस्वीर छपती रहे, क्या शोभा देता है? क्या मेरे देश के पास ऐसे उद्योगकार नहीं है क्या? उनको कंपल किया जाए कि तुम्हें ये फैक्ट्री लगानी है, पैसा चाहिए दूंगा, लेकिन ये लगाओ पागल, लाओ दुनिया से टेक्नोलॉजी लाओ, और हमारी करेंसी कागज हिंदुस्तानी होना चाहिए, इंक भी हिंदुस्तानी होनी चाहिए। और मैं चाहता हूं कि आरबीआई इस बात को एक जिम्मेवारी समझ करके एक नेतृत्व दे। ये बदलाव के ये मेक इन इंडिया तो यहीं से शुरू होता है।
So after this initiative, we developed some pigment, and we also covered after 2 or 3 years after this.
सुरक्षा के तमाम उपाय करने के बावजूद नकली नोटों पर पूरी तरह से लगाम नहीं लगती है, लेकिन अब नेशनल फिजिकल लैबोरेटरी यानी कि एनपीएल एक ऐसी स्याही तैयार कर रहा है जो नकली नोट के धंधेबाज को पूरी तरह से फेल कर देगी। एनपीएल का दावा है कि इस स्याही के इस्तेमाल से जो नोट बनेंगे उनकी नकल नामुमकिन होगी। वित्त मंत्रालय और नीति आयोग को इस स्याही का प्रस्ताव दे दिया गया है।
जिस गांधी ने स्वदेशी के लिए इतनी लड़ाई लड़ी, वो विदेशी कागज तो उसकी तस्वीर छपती रहे, क्या शोभा देता है? क्या
नोट छापने के लिए स्वदेशी स्याही की बात की थी, तब किसी के पास इसका जवाब नहीं था, लेकिन अब नेशनल फिजिकल लैबोरेटरी ऐसी स्याही बना ली है जिसका कोई तोड़ नहीं है। एनपीएल का दावा है कि ये दुनिया की पहली स्याही है जो 2 रंगों में बनी है, लिहाजा इस स्याही से जो नोट बनेंगे उनकी नकल नामुमकिन है।
जैसा कि हमने 2 तरह के इंक बनाए हैं, एक तो व्हाइट कलर का दिख रहा है और दूसरा ऑलमोस्ट ट्रांसपेरेंट है,
बनाए जा सकेंगे।
तो जब तक ये so I am here, so I will discuss details, so it is better to see the video, just like to glimpse to for the youngsters to how it's impact.
Soon the people of India will not have to worry about the fake notes or documents, as Indian scientists have come up with an innovative solution to tackle this problem. The scientists at CSIR-NPL have developed an unclonable ink that can be used to give a unique mark to legal tenders. Having completed all the tests, this application can soon be used in important documents like stamp papers, passports, and currency notes. To know more about this interesting development, let us see how
notes form the backbone of our economy. But presence of counterfeit currency among them has a negative impact not only on our economy, but also on our reputation. To solve this problem, New Delhi-based CSIR.
So I will more detailed discuss. So before I can start directly the work. So first, because students are here, so just make the foundation for this area, how we can understand the fluorescence and what kind of the fluorescence technique we can able to make this kind of the pigment, and ultimately what is the behind the idea is to develop this kind of the pigment. So first I can define the luminescence. Luminescence, nothing but an emission of photon by electrically excited atoms or molecule, is known as luminescence. It's a broadly you can define as, because why broadly? Because there is two type of the material, like the inorganic and organic base. So that's why broadly I am trying to describe. But you see the types of the luminescence, like electroluminescence, chemiluminescence, radioluminescence, sonoluminescence, cathodoluminescence, photoluminescence. There is a cost to excite to put the energy to the host lattice, like electrical current or like chemical reaction or like high energy particles or like intense sound waves or like cathode rays or like photons. And there's examples how these are kind of the compound that can be used for the different kind of the fluorescent technique. So how we can understand first? So this is you can say the father of the fluorescence can be the phenomena understand by the Jablonski diagram. So basically this diagram, basically what they tell us, this diagram, if you see the spectroscopic technique, there is selection rule for the forbidden and the allowed. So if you understand that, for that we have to measure, if you see the process, there's a process like the ground state, and if you put the light, then the excited state. And excited, there is two kind of the vibrations, like vibrational energy states or like internal conversion. If internal conversion, anything not coming in the transition, that can be non-radiative. If coming in the transition, that will be radiative. And first part is, you see the left side, it is called as a fluorescence, and lifetime is 10⁻⁹ to 10⁻⁴ second. Like the one best example is tube light, right? And if you see the transitions, it's like singlet to singlet transitions. When you talk about the phosphorescence, the lifetime and spin parity is opposite in case of the fluorescence. But if you talk about the phosphorescence, like the afterglow, the transition, if you see the spin is same direction, like spin parity is not opposite in the same direction in case of the phosphorescence. And if you see the why it's called as the afterglow delay, because if you see the first it is ground state, if you put some light on this kind of host, it excited and then it reached to excited state level and the internal conversion loss, and then convert into delay fluorescence. So it's another metastable state and then comes to ground state. So that's why it's called a triplet to singlet, and lifetime is 10⁻³ to 10⁻² second. So if you compare with this lifetime to the fluorescence lifetime, it's a very important that both has a different lifetime. And I will give you a best example of how you can do the miracle by understanding the phenomena. I will give you an example for that. So how we can first choose the host material or like activator or sensitizer, because three main things in the luminescent material, if you see here. So host is to the responsibility to absorb the light, and the sensitizer role is to convert the light into activator, and activator role is to very quick to take the transition of the excess energy. So ultimately, three things are very important: host, activator, and sensitizer. So how we can select it? Host means if you absorb more light, it means can be best host. If you take the activator, means like europium, terbium, dysprosium. Why? Lanthanide series, because it's outermost and second outermost are incomplete. So if you're putting the light, easy to make the transition like FF or FD. I will more detail discuss in later slide. And talk about the sensitizer. If some intermediate is required in some kind of the material, then use as a sensitizer, like terbium used in the up conversion. So why this kind of the terminology use up conversion, those things I will discuss in the next few slides. So first you can understand why the lanthanide series used for the activators in the rare dope kind of the material. So you can see here if you see the outermost electronic configuration and oxidation state, it's very important to, very easy to make the europium 3+ stable and make the transitions. So that's why europium, terbium, dysprosium, according to the transition, we can assign, emit the colors like the red, green, and blue. And if you see the up conversion, because it's 2-photon process, so that's why need the sensitizer. And many cases, if you see, even sensitizer is not needed, like defect-induced emission. Like if you talk about the zinc oxide, if you do the in a high temperature, it's emitting the oxygen vacancy. Due to oxygen vacancy, they emit the green color. So basically, there is no need to any sensitizer. They can directly emit after the absorb the light. So it means that kind of the host is work for the not only the host lattice but also the sensitizer. So you try to understand by this phenomena now. So best example is tube light. When I joined here, because why we are lacking the technology, friends, you can understand, we never bother about the technology. Like if you have the mobile and anything problem coming in the mobile, we have no option other than go to market. If people, it may be they have the less than even ITI, and we have the degree of the PhD, we have no option to just to depend upon them, because we never think about the technology, because only we use the technology but never realize the technology. So this is the culture we have to change. That's why Make in India, Made in India is important. But around scenario, whatever the day to day we are using, our responsibility to understand the phenomena. Otherwise, all gadgets we are using from the import, and ultimately GDP is going to down. So how we can innovate the things? We innovate the things by the proper understanding and willpower, and trying to make the force of the understanding for the any technology before use. At least academic person can do, like people like student in class 12, 10th, BSc, MSc, or PhD. At least they should realize. So if they will realize, they can share knowledge to among the common people. So ultimately, this kind of technology can be realized, and nobody can trade with their technology. So if you see the example, I can say the tube light. Initially, when it started the tube light, the same calcium apatite is going to use for the fluorescence, because the tube light is not much efficient producing the light. What is the basic phenomenon tube light? If you see inside, there is a xenon and going to discharge by the electrode, and ultimately xenon producing the UV light, and there is phosphor of the coating on the surface, like the slurry white color showing. Or ultimately, if you see the new kind of the tube light, there is a red, green, and blue phosphor or luminescent material, and if you excite it, then they're producing like 60, 30, 10% of the combination. Ultimately, RGB is converted into white light. So nowadays, if you see the even LEDs, so LED, if you see, there is a blue LED and trying to coat out the yellow phosphor like the cerium and convert into white light. Even if you see the LED story, the guy they are getting the Nobel Prize in 2014. They early, when we started this kind of the work even many years ago, and they proposed to company kicked him and said like that this kind of the blue LED there is no use. But because of the blue LEDs, we are able to get the red LEDs and the white light and the green LEDs. So blue LEDs was the combination for the different kind of the generation of the material. So ultimately started from the blue, the guy, the Nakamura, and after the kicking, the company realized after many years later, and they making a patent file. And because of the almost like 30 to 40 years, those kind of the fight going on the court, and ultimately the guy, the court decision was the guy involved in the invention, they cannot be even part of the company, but they the copyright of the discovery. So that's why they should be shared. So ultimately, that discovery going to realize, because common people that time using the LED everywhere, and ultimately getting the Nobel Prize. So these things are very important to sensitize the youngsters. So how we can discover and how much time to recognize those kind of discovery. So if you want to luminescent material, you have to idea about all kind of the semiconductors, not like the rare earth waste or rare earth dope. So that's why we also talk about the semiconductor nanocrystals, how they are emitting the light. So if you excite the semiconductor and put the light, then the valence band electron is going to excite it and release a hole and going to conduction band, and ultimately in the higher energy state again it come to highest energy state and convert it to again the ground state, and recombination of the electron hole basically produce the photon, and ultimately that photon we are realized as a luminescence. So if you change the size, I already told how the band gap is going to change, you can tailor the fluorescence. So if you talk about the carbon materials, in the carbon materials, if you pure carbon system, then only delocalized pi electron density is high. There is no kind of the hole, like when if you excite it, even though, because only if you excite it, then what will be the non-radiative part will be very high. No radiative part will become, because we require the hole. Without the hole and electron recombination, it is impossible to generate the light. But if you do the like quantum dot, what you are doing, you hydrolyze the carbon system and trying to add the functional group. The adding of the functional group, what happened? The protonation power is going to enhance. So if you have the hole with the electron, then recombination will be going to increase. So density of the recombination will increase. Ultimately, we are seeing the bright light. So if you sp2 cluster only, you cannot able to realize the photon. But if you sp2 cluster means delocalized pi electron with host, then you can realize the brightness. Another kind of the material like MOFs, metal organic framework. People is very clever and the greedy always to discover something new. If you see in this, what they trying to, they make an organic cage and trying to absorb more and more light, and especially they decorated the metal on the surface and trying to make the host and activator system is like efficient system to all energy can be converted into host. Why? If you do the solid state diffusion, there is a need high temperature, as well as there is some limits for the energy transfer because of the solid lattice, because of the repetition of the unit cell and the fixed position of the atoms in the unit cell. But in case of the organic cage, you can design a cage where you can design more and more energy can be accommodate, and you can decorate especially the side where easy to make the metal to the adjoint and trying to energy transfer. But this kind of the material only suffers because of the fact that because of the low yield of the synthesis. So another kind of the material you can do like plasmonic material, like theoretically people predicted that if you incident a confinement plasmon material, the incident light, it can be reflected back the light at about 4 times higher. Although it's not realized till date, but because of the, if you see here, what will be happen if you incident the light of the any metal, they start the plasmon oscillation for a, like if you consider the system as a sphere, and displacement of the conduction electron charge could relatively nuclei. So if you see the electric vectors, it's going to shift it. So the difference in the energy, it's reflect back that energy, and that's supposed to that kind of the vibration can possible up to that level ke energy can be incident, and if the energy of the reflect back ratio almost like 10^4 times. But people trying to do then many kind of the like aluminum, silver, and gold. Aluminum suffers from the stable nature in the air, but most of the people working of the plasmonic material like gold or silver. So another kind of the material which I already told, like a pure system, if there is some defect during the coherence length, then also you can produce the light. But those point of the photon yield will be very low. So before you start any material, any projection for the particular application, you need to check all kind of the systematically the knowledge. If you don't have the knowledge, you cannot randomly any discovery can do. So this is the review article. I told about all kind of the material, how we chosen and how a anti-counterfeiting material can be designed. So now question comes, why this is a national importance of the project? It's very important to understand, because if you see the new currency, there is 17 feature. And if you see the current scenario, even 500 rupees note after the new currency, the counterfeiting is more than 100 times per day, a single note. So you will be surprised how its economy is going to damage. If you talk about the big notes like the higher denomination like 2000 rupees note, that is also like almost 22%. So you can understand that this is not my data. This is data from the printing press, where the security kind of the force task force is there. They are evaluating our currency these values. So if you see the carefully our note, there is two main features. One is color shift feature, another is fluorescent feature for the common people. But those features we are importing from the abroad, like color shift feature is 1,60,000 rupees per kg. So thousands of metric tons we are using for the printing the currency, and you can understand how much economy is going to invest in that. Similarly, fluorescent features is more than $800 per kg. So only the European one country from the even before independence, they supply till date, and they purposely given the detector, and that is the designed by the UK people. Even many factory is opened before independence during the UK by the British. So ultimately, because of we have the same cotton paper printing manufacturing, and same we have the printing press like our neighbor countries. So ultimately they are able to, if import the higher security features, they can print the currency. We can say the fake, but ultimately they will realize you to real. It's not like fake, like some kind of the like illusion. It's kind of real note. If they note the series and numbers, you cannot identify which one is real. So ultimately, if you see 1 year data, it's like 1,200 crores the counterfeit money. So that's why our Prime Minister initiated, and this is I have given data for the only one kind of the currency. But if you see currency, stamp paper, bank checks, many places this kind of security feature is there. So ultimately, that's why this kind of the research is very important. And when I started the research in 2010, 2007, nobody almost like they talk about the fluorescence and like they talk about the like they see the thumb impression, but talk about the after 2010 when first published, you can say the data they started to talk about the anti-counterfeiting technology. So that is the reason we want to emphasize this kind of the and if you see this kind of the counterfeiting is happen, a lot of job is going to per year. In France, if you see the worldwide data, they lost because of the counterfeiting. So such kind of the crime to stop, not only the worldwide, by the nation also, we have required the indigenous development. So ultimately, if you see, we developed some pigment, and how we are claiming, I can just to putting the place by slowly to understand. You can also, like if you see the old currency note and new currency note put in the UV box, and you put the UV light, it will glow in the old currency note the red color, and there is no color shift pigment in earlier people used. If you see the new currency note, there is a color shift pigment as well as the luminescent. So these are the two main features. Although there are several features, and people to sensitize government time to time saying the Jago India Jago, and there is several rest features. Why I am not talking about? Who bother about your note is triangle, or who bother about your note is marking? Because there is some purpose. So those kind of the marking is there for the like visually impaired people, for they can just to touch it and understand. But even the visual people, they don't care about these kind of the features. So it's a very important to sensitize the features and understand how you can know the fake and real. So even for those purpose, if you now I can just to focus to two things, like fluorescent as well as the color shift, which is we developed in the CSIR-National. If you see in the currency note where we want to place it, the red one is like the luminescent, which is we make the rectangle, and the green one is the color shift. So we have the two places the color shift, but you cannot able to one place to see the color shift effect because our paper is the fibrous paper. So if you put the light, it's absorb the light, so color effect is very less. We are importing the pigment, and there is no science to understand. We are putting the printing. Ultimately, we are not getting the color shift effect in this portion. Particularly, I am saying this portion. If you see the marker, this portion. If you're trying to see this portion, like the band is metallic, so there is some alloy. So if you're putting there only you can able to see the color change. Like in 0 degree green, if you tilt it to 45 degrees, then it will be blue. So how our pigments are different and how we are developing this. If you compare it by this, if you see our pigment, if you print it, it will show like invisible or visible according to your desire. And if you excite it, the one frequency, it will showing the one color. If you change the frequency, it will change the color. Means dynamic change security features. Now that is the only static security features. So that's why dynamic security feature is more important than the static, and it's difficult to counterfeit. Similarly, in the passport, they can do like red to blue. So if you compare it, why we are saying the most strong? So comparison is very important. Before just to place to any what is mind, this is best or this is not good. So you can see, compare, we have the two security features and more brightness than what we are using now from the import. So ultimately we propose to government. And if you see this security features, compare with the security feature what we are using in the currency notes, our quantum is much higher than what we are importing. So ultimately, if you compare with the worldwide any currency, no one has such kind of the feature. So ultimately we propose to government for the stamp paper, bank checks, many places, and we are making different kind of the pigments. Like if you compare the passport, there is security feature in the left side, the green color, and especially embossing the gold foil. So it's a very expensive technique. So we make a golden ink. If you print it, there's a security feature is hidden. So if you excite it one frequency, the golden same envelope is going to green, and if you change the frequency, it will be red. So similarly, we are thinking for the QR codes and as a certificates. So nothing is going to counterfeit. So ultimately, we done the these kind of the rigorously the pigment, ink, and everything. Without exercise, you cannot reach the industry for the any kind of the use, because you are supposed to develop a button. Nobody will make the cert according to you. So you have to make the button according to the cert. Then your technology will be going to successful. So similarly, first we realize offset printing, what kind of printing press is there, and then according to we make the ink. So similarly, we are making luminomatic ink, because you see the bank checks, they have the separately the MICR code, the magnetic ink, and separately they are putting the luminescence feature of the left top. So we are making a material that can be luminomagnetic, and we have the both security feature as compared to the single feature, and they separately printing in 2 places. It's a more expensive process. So if you see here this video, I can show you this is how the luminomatic can be seen here. Now you can see if you put the 365, it's like the fluorescent, and if you put the magnet near to that, so realization is very important to understand these kind of the features. So another is I am seeing the angle dependent fluorescent features. They're trying to see the someone can make like this kind of feature. So they start to search, and the government also come to us, and ultimately we taken the challenge and the color shift features on the deposition and taking out the pigment from the deposited layer, and ultimately we printed it. So I will just to go in another kind of the feature we have developed. That is the feature is based on NIR based. Suppose if you want to stop the smuggling of the currency, so how you can stop it? So you need to take citation source. People cannot understand by the naked eye, cannot see by the naked eye, and but if you excite it, it will show the color. So what we had make, we make a pigment, and with the pigment, if you excite with the NIR, it will show the color, and the color which it's showing, same kind of the photo response small cells are printed there. So if color is green, photo response cell will give the signal, like the mobile giving the signal, and if search pole there is an NIR detector, they will just say like that a bundle of, we have the many ideas for this kind of even security paper how can make this strong. So we are making the pigment for the tag ends for the paper that cannot even disturb the security feature of the currency, but it can authenticate the paper also. So we made so many kind of the color shift as government, and time to time Make in India program, they also the Nature India appreciate our work for the passport or currency. So ultimately I like to say like that, if you see this results, basically what's happened, I am trying to show there how a basic research into use for the self-reliant indigenous technology, which will cut down our dependence to import technology raw materials, and essentially to lead a saving of foreign exchange. So this is one kind of the example I can show you. So when I started the work in 2010, this is the first I start the work. That time we started single excitation, single emission kind of the material. It's simple, because if you start anything, then you have to understand the how your work is more advanced. Then we are making the bioluminescent and bioluminescent emission kind of the pigment, and you can see here. And we are trying to also parallelly to understand the medium, because if you are focus a very innovative kind of the pigment, because that's why I'm passing few slides here. So if you see, also we are trying to PL mapping to understand if fluorescence intensity is going to distribution is uniform or not. So ultimately all kind of the concept then we are utilized for the printing the start from the we done the 2D, 3D kind of the examination for the after printing, and ultimately we developed so many pigments. But I will go for only one pigment, which is very important and is very innovative. So I'm just putting your eye to catch there, because we make the bioluminescent, triluminescent. You can see this is the triluminescent, like 2 UV and 1 NIR. And ultimately, this is the pigment I want to discuss in detail, because I earlier told, like, if you understand the phenomena, you can do the miracle in the fluorescent material. Like if you see this work here, we are trying to use the Jablonski diagram. When we are said like one is the fluorescent, one is the phosphorus. How we are making the differentiate by the lifetime, and we make a compound where two compound in a associated in a single host, and both have the lifetime different. So if you switch on, it will be red. If you switch off, it will be green. So a kind of the miracle kind of the pigment. And ultimately, if you see here, if you switch on, it will show the red color. If you switch off, it will be green. How you will realize really, because we have done the all kind of tests like the humidity, temperature, and chemical resistance and viscosity, and ultimately how we selected this material, because so many selectivity we have tried, and ultimately we found some kind of the pigment. And this work was in the Hindu cover page on the news, and also in the discovery of top 11 discovery in among number 1 in 2019. So you can realize it, how it's look like, and how it's sample inside the sample holder in normal light. So you can see white color, body color is coming in normal light. So you can see in the close view also, it's a white. So once we can switch on the UV and switch off the normal light, then you can see its color is red. So you can see it's red in UV light. So now can you switch off the UV light, please? Yes. So now you can see. So it's like magic. So means like so many kinds of the pigments we have developed here. Similarly, we developed for the bank checks. Already I told about that the magnetic and the luminescent behavior. So this kind of the work is also appreciated in many places. And if you want to understand that the conversation between a neuro person as well as the me, how we can debate for the how our currency is going to protect. So this is the Nature India platform. There is a conversation like the podcast interview. So normally the expert interviews are there. One of them is for the anti-counterfeiting. That kind of the talk is there. So you can trying to how an Arpan Banerjee and my views are for the counterfeiting. So ultimately, we are doing science for the society. No doubt about that. That's why many places this kind of the work is going to appreciated, and this work is also in the part of the highly cited. So another kind of the pigment I will discuss about, because as you know that the election ink is developed from the CSIR-NPL. I don't know that you know, or I just want to aware. In 1952, when the Prime Minister came and they said like the double voting is a big problem, because after the independence there is a big problem for the election, because people trying to do the double voting. It's very difficult for the any kind of, they said any kind of the mark can possible, that can we stop the double voting. That time they came, and here in NPL Professor Siddiqui was there and a team of the Professor Agrawal. So basically they sample, and they're trying to show them, if you put it, this is a silver based some kind of sample, and put on the finger, it will be blue, and time to time it will be black, and it will persist for 2 to 3 days or 4 days, 8 up to 7 days even. So that kind of the concept, we thought why not we can do something new, and parallelly the Mysore paint we earlier ink that already want to European countries, they don't want to blue kind of the ink, they want to use the ink that can be invisible on the skin, but if you excite it, it can show the color. So we make a ink that can be invisible if you put it on the finger, and parallelly we made also device. So if you see here, we put on the finger, it will be invisible, and if you put on the UV light, and they're showing the color. So we done the all kind of the test. So the work is under progress for the given this technology to Europe for their election. So this work was covered in the Hindu cover page for this kind of new ink. Another kind of the challenge we taken the COVID-19. So last year, as you know that the RT-PCR is the very cumbersome technique and taking a lot of time. So we try to understand first what is the coronavirus structure and how this kind of the spike protein is going to attack, and how this spike protein structure can be replicated in some primer. And if suppose we want to detect it, how that primer can conjugate with the fluorescent particle. So idea was to like that, if you make suppose some fluorescent particle and trying to make some primer that can conjugate one side from the particle like the afterglow, and another side is like the coronavirus, then easy to detect by the our normal mobile. So that the beauty of this kind of the technique, because spectroscopic technique. So within a few seconds, it can be see the virus is going to have the presence or not, because you can just to excite it and close the light. If you close the light after glow, in nature is it will glow after switch off the light. Then the signal by noise ratio will be very high. So using that science, we are trying to enhance the sensitization of the detection and a quick time to detect. And that project is just we completed in December 2021, and now the sample is under trial. And hope some company biotech or they can this kind of the technique will be also the part of the other technique, like people using RT-PCR and other technique. And people also trying to mask and other for the MIT researcher parallelly what we are trying in our place. But there the UV excitable, and we are making the normal mobile excitable. So we want to common people can understand easy as compared to the UV based any kind of technology. So other kind of the work also, I work for the luminomagnetic kind of the material for the drug delivery, but I will not go in the detail. But I can say like only if you understand the diagnostic or therapy, then accordingly you can make the contrast agent. Like we want to some contrast agent like fluorescent probe as well as the magnetic. Why? Because we are using the gadolinium chelate separately for the MRI and separately for the luminescent probe for the tracking. So better to we can make it the material that can fluorescent and the magnetic. So that view we are able to making a material. So I will not go detail in these things, but only you can say my nature is always to show this kind of the work by very simple way. So you can see here, this just taken a magnet, and after making the compound, if you see here, if switch on the UV light, it's glowing, and if you see the band with respect to time, it's going to band is going to clearly visible, because the magnet is trying to track the magnetic nanoparticle. Ultimately, if you see after 16 minutes, this kind of the band is going to clearly visible. So this kind of the another application I shown here. So I also make some nanostructures that can be directly attached to the cancer cell, like this cancer cell. Our aim was to that, and trying to, because of the rod shape, it can just to capturing the nucleus. So we are also trying this kind of work with Baylor College of Medicine, USA, and this was many kind of the new materials fluorescent we developed in last few years, like the BCNO kind of the 2D new luminescent material that can tailor from the blue to red, and that tailoring can possibly be defect centers by nitrogen and carbon ratio. So we also work on the LEDs. Because of the, I will not talk about much about the LEDs, but I will say again another kind of the challenge recently I taken regarding the blue laser induced white light. This is a new futuristic light. But before you try to any technology or any work, if you have the understanding, that only you can develop. Like you can see here, a company FIAM came to us and they said, because the GM GM Motors and BMW trying to high-end cars the laser induced light. So can you make some material that can be sustain the laser and that can possible to make the car headlight? So we taken the project, right? Because these are the LEDs. So I will just go that project. So we make a material that can excite with the blue laser and convert into white light. So we taken the challenge from the FIAM company, one of the biggest company in the Sonipat. They making the car headlights, and we making a material. And before I can show why they are trying, you can see this video. So basic idea of this technology to it can penetrate high alarm from the when train was in longer distance. Like one example of the, so we make this kind of the prototype that can penetrate more than 5 meters, and they can induce by the white light from the blue laser, and we shown by reflection mode and transmission mode. So this is the prototype device we shown, and we compared with the halogen and laser and the other sources of the headlight, and we found that this is the one of the highest penetration as compared to any kind of they made for the sources like halogen or like LEDs. And ultimately we shown the Professor Joshi also this kind of our invention, and also the CMD of the FIAM Industries. So ultimately they given the second phase project, and now we shown this kind of the prototype to many of the two-wheelers company, and they are ready to make this kind of the headlights. They're given a project to design the real headlights, and we are now in the process. So this kind of the project we shown to Yamaha and the many other companies like the Bajaj or like the many more companies, and they called us for this prototype to understand, and we shown them. So ultimately, the last the work because you realize for the energy. So obviously, I will discuss about something about the what is my story started from the technology when I was doing the PhD. So basically, I will few things discuss about the hydrogen energy very quickly, because if you see, when I started my journey from the PhD, I make the material, I realize the material, I feel the material, I put in the technology, I realize the technology, and I experience the technology myself after running the two-wheeler. So ultimately, because this professor is no more, last year I already told Professor Owen Srivastava is no more. So in his memory, I also make a small article to just to sensitize to people how a person contribute this technology in India. So this is an article in hydrogen energy. So any can go through. So I will just to show you the real drive, because it's a very interesting. When I was a PhD student, and this kind of the bike is going to be developed, and myself, I'm running on the hydrogen, and this is my supervisor. He's also running the motorcycle, Professor Owen Srivastava. And also this news and views, this article was covered. So if you see here, this one myself. So basically, this is a hydrogen fueled motorcycle. Basically, we store hydrogen in metal hydride. So I will quickly go to in detail, because my whole PhD was the 3-step like kind of the classified, like metal hydride I'm working, like the carbon nanostructure I'm working, and LNAs. So ultimately, if you see here, why we are using the hydrogen, if you use the hydrogen, after burning the hydrogen, again, it can be combined with the oxygen and then convert into water. So means recycling of the water. So if you see the scenario of the challenge of the decarbonization global, people trying to reduce the carbon in the worldwide. And if you see the scenario of the discovery of the fuel, so start from the fuel wood, so very less kind of the hydrogen, but more coverage from the carbon. So slowly, if the science is going to progress, what we are doing, we are trying to reduce the carbon, and ultimately, if you reduce 100% carbon, ultimately you can see here the hydrogen, right? So this is the no alternative option other than the hydrogen in coming future. So if you see the worldwide rank of the India consumption, so energy required more, and energy generated by us is less. So it is very important if you want to like some economy to support like 5 trillion, we have required some technology like this, which is independent of the oil, and we can save our economy and we can contribute to country. So there is a, if you see the scenario, that time we already predicted, if we are not able to reduce the carbon, the scenario will be same like what putting the mask. One reason is for the if you see one reason from the coronavirus, but other reason also for the pollution. So if you see the economy, how going to affect, so 70% our import is in foreign exchange is going to import the oil. And if like the current scenario, like the Ukraine and Russia is going to battle, you can see the situation, how the oil rate is going to change. And ultimately, without any contribution in in this kind of the fight, ultimately we also in the part of the damage the economy. So ultimately, if we want to some freedom fuel, we have to think about the hydrogen. So there is several routes to produce the hydrogen, and if you what kind of the outcome will be there. If you compared with the gasoline and the other the carbon system, so it is a clean fuel as compared to any other fuel. If you're trying to understand how this technology can possible, there is two techniques like combustion or like fuel cell. So if you make a hydrogen kind of the concept in India, we have required these things: production, storage, transport, and application. Otherwise, it's very difficult. So made like electrolysis and chemical conversion of the hydrogen and the biological route. They three route trying to industry to making the domestic or from the domestic waste they want to convert into like alkali industries or ghee industries. They are using for the like hydrocarbons. So if you segregate the hydrogen from there or like purification of the petroleum, so a lot of hydrogen going to waste. If you're trying to convert into as a fuel to use for the applications, it can possible. So that's why storage is very important. So if you think why hydrogen, so you can understand because most abundant element on the earth, clean combustion and delivery energy, if you see per mass of the hydrogen is very high as compared to any gas. If you try to compare with the methane, propane, butane, ethanol, methanol, diesel, gasoline, so hydrogen is a great future, even 3 times higher than the even if you compare with the methane. So ultimately, if you see the striking property of the hydrogen, so if you see here, if you compare the hydrogen, methane, and gasoline, hydrogen has the lower heating value and self-ignition temperature is 585. Although self-ignition temperature is high, but it can be activated by the other method to at low temperature. But the flame temperature is very high. So we have required, if you want to internal combustion, there is coating. So that cannot be, to destroy the carburetor. If you because such much high temperature, you have to some shielding is required inside the compression during the if you intake the hydrogen in internal combustion. Similarly, many striking parameters I am writing here. So I already told about the how hydrogen economy can possible. So basically, why we want to store? There is some logic behind the storage. So if you see here, if suppose hydrogen at gas at NTP, lightest gas density is 0.0892 gram per liter and 7% density of the air. So if hydrogen you directly use, then buoyancy effect will be leak hydrogen in the atmosphere has to be stored if liquid hydrogen you are talking. If no storage would be the best option, but it's very difficult. So reform the development of the nearly stop in USA. So but in India still we are thinking, and worldwide also they are thinking so several material, and they're putting some benchmark how much hydrogen can be stored and how it can be more commercialized. But if you see the scenario, like few materials like the Mg or like the Mg2Ni or like vanadium, but very difficult to dissolve the hydrogen. That time we work on the metal hydride because it's a thermodynamic is very good, and if you see the exhaust temperature of the engine, it's a very good thermodynamic for the, and it's based on the exothermic and in metal to metal hydride and metal hydride to the hydrogen liberation and again convert to metal. So there is 3 kind of the material I am working here that time. So ultimately, if you see worldwide, there is many countries, they have the theoretical studies they have done as well as the experimental. So ultimately, if you go to importance for the India, there's many centers for the hydrogen. But I am surprised to see when you see the board of the hydrogen in currently like the Tata and the Ambani and other groups are there, but hardly few scientists they really how can be this economic and possible, because we are trying to again import the things from the Belgium. So my idea is to again to put all the hydrogen the ambassadors, they can come together and they can combine their efforts in the technology, they can demonstrate it. So what are the key parameters where we are lacking for the internal combustion? One key parameters to more hydrogen storage should be possible. If then it can be possible to commercialize. Second thing is the injector is the gas injector required to design, because all the injectors based on the liquid to gas conversion, because we are first to impinge the liquid inside the chamber for the injection and trying to spray it. But if you spray the gas, it will be back force will be just to escape the same place where the hydrogen trying to feed. And second is the compression ratio required is very high, because the injector is like, if this distance will be the piston and the chamber will be very distant, then the hydrogen will be backfire. So many things are required to design. So that's why the metal hydride we have chosen. And ultimately, why metal hydride? Because if you store metal hydride, although the storage capacity very less, but even though if you store it will be safe. So at least you can demonstrate those kind of the metal hydride base. And there's a science behind that, the how you can choose again the metal hydride and where the hydrogen is going to store, like the two kind of the metal hydride, the voids, like the tetrahedral void and octahedral voids. If you see the hydrogen kinetic diameter 2.89, so according to the void, the space, hydrogen can sit like the ionic form, like hydride phase, means valency of the hydrogen in hydride phase is -1. Normally, if you see the anywhere, hydrogen valency is +1. So I have keep an idea in my mind. Why not we can make a device that can be fully hydrogen based, and that can be two membranes. One membrane containing the hydrogen with the -1 valency, another hydrogen like the protonate by the like Nafion kind of the membrane, they can use the plus hydrogen valency. And if you try to recombine it, then the lightest cell will be there instead of in lithium or any kind of the battery. But very challenging to control it, very challenging to how we can separate it, very challenging to how much the thin layer can possible with the metal hydride. And another challenge was to how we can make the air stable metal hydride. So that's why, and these are the one-half equations, like how the metal first go to hydrogen inside the metal. So first hydrogen molecule, if you strike with the surface of the metal, it dissociated hydrogen ion, and because like suppose Mg to Ni role is to dissociate the hydrogen into hydrogen ion, molecule to ion, and it's going to interstitial voids like octahedral, tetrahedral voids. According, it's going to make the adsorption, and ultimately it's going to saturate like alpha plus beta phase, and like alpha phase is metal, alpha plus beta is metal hydride, and beta phase when hydrogen is going to liberate. So if you see here one-half equation, you can also simulate it to how much empirical formula of the material and how the compound can be also trying to predict it. So if you see the charging discharging behavior of the metal hydride, so endothermic when discharging, exothermic is going to charge. So it can be to all, because it's a already a lot of time required to take, but I can show you how metal hydride is going to synthesized. Now I will go to very challenging part. That is very important to show, because Ankur is there, they realize that part. We make one day after 2006 when I finished my PhD, then I asked to my boss, sir, metal hydride is still air stable or not? Then he said, same problem still we are facing. So I said, I have one idea. They said, you have always come to idea, but metal hydride point of view, I need to check it. I will not, without checking, we will use for the, we can, what is the idea? I can just to tell you. Because these things are many time, it will take a lot of time. So many structures I made during the hydrogen storage in the different kind of the carbon nanostructures. So I will just to go in that idea. I am always believing in simplest. So one day when I am not able to put the air sensitive material inside the outside the in the table to do the any kind of the conversion in the reactor, we make the just mixing from my house and trying to ball milling in the chamber, in the vacuum chamber, and trying to same place you can transfer in the hydrogen storage tank. So these kind of the practice we have to require if you have the good understanding. So ultimately I can just to quickly to just to pass on this thing, and I will go to new that. Yes. So this is the 2017 story. So I told to my boss, I sitting a talk and I listen very carefully. A bio person talking about the how plants making the food. Then he said, what is the relation with the metal hydride? Then said, I start working on the graphene, and same annihilation nature I seen in the graphene to annihilate the oxygen. And ethyl cellulose also the nature when making the food in the plant, they annihilate the oxygen. If we combine these two things like ethyl cellulose with the graphene, definitely we can protect the metal hydride. He didn't believe. I said I will demonstrate it, and ultimately one person came to our lab and we coated the metal hydride with our composite, and ultimately I will show the video. So you can see this video. Before coating, I will first show you, because I always believe in demonstration. If you say anyone to, don't need to just to accept without demonstration. So you can see here. So we make a device, and we can just do metal hydride and charge the metal hydride for the some device. And you can see here, there is no coating, and we see the efficiency of the metal hydride. It's running the fuel cell, right? And then you can see here, after the use of these metal hydride in the fuel cell, we are trying to take outside, and you can see the scenario. If you are putting the air without coating, you can see the scenario. Within few seconds, in air, it's a pyrophoric nature. It's just burning. And burning is not like a simple burning. You can see here. So there is no directly method to control the metal hydride once you use the hydrogen. So what we had done, we coated this kind of the material with the same concept. What I listened in the talk, how the plants make the food, and we make the material that can be more inhalation, because the by nature of the graphene and the ethyl cellulose. And you can see this situation. If you take outside, then there is no burning. Even you can leave it for longer. So my idea was to how we can make a layer for the metal hydride based, and they can air stable. So that is the idea to demonstrate here. So ultimately, if you done the 30 cycle, even though we realize that it's a stable. So ultimately, we realize that this kind of the material can possible to like you can see after 30 cycle also this material is not burning, and then 1000 cycle we checked. So ultimately I can say, if you have the right concept of the material, definitely you can do the wonders. So there is a basic diagram when you start from the hydrogen in the motorcycle. That time metal hydride tank was the left side, then we work there and on the top side, and still a lot of things are going for the other devices, for the like you can use for the generator, you can use for the 3-wheelers, you can use for the burner. So idea is to, like, if you are working in somewhere, it is very important to think continuously. Don't leave it. Just to leave it, it means you just to, there is no use of such kind of the work. So ultimately, we also compare this motorcycle with the Japanese motorcycle or like car. And if you even filling station also we seen there when I got the chance for the Japan to see this kind of the Yokohama, to see the technology. And ultimately, I thankful to my supervisor. When I was doing the PhD, I get the motivation. A lot of good scientists like Professor Chidambaram, Professor Sierna Rao, S.K. Joshi, and like many dignitaries. So ultimately, I can want to say to youngsters, controversy always create challenge, but challenges create advancement, progress, and new thoughts in research with motivation and hard work. New thoughts create success. That's why I don't want to say more. So thank you. So if any question, definitely I will be happy to answer.
Thank you so much, sir. It was really very nice, informative session. And we have so many questions in the chat box. So let us take them one by one. First question is from Remya R. Nair. Can you please discuss little bit more about the work related to luminescent polymeric nanofiber matte for white security paper? Which luminescent chemical is used with polymer in this work?
Yeah, sure. Actually, this kind of the work is very important to, I just to see the, how if you make the paper cellulose fiber, that time you can fluorescent material. That should be only the part is the invisible. So if you're making the ethyl cellulose based fiber, if you impinge the solution to incorporate this kind of the luminescent material, then you can make a paper that can be authenticated by is it fake or real by that security feature. So why I am trying to this, because we are importing those kind of paper and the device from the abroad. I was very surprised when we visited the BNP Devas where the currency note is going to print. So I was surprised to see, because even paper tagant we cannot make ourselves. So even Hoshangabad, the paper they make, but the tagant come from the abroad, and that tagant incorporated during the paper manufacturing, and their device they themselves they making, and they said if you just touch it device to like any kind of the scientific exercise, it will not work. So they are not even want to touch any kind of the science to people can do. So I was laughing like that, because if you make the security feature that is the NIR range, so you can make the something like that cannot be interfere the security feature of the paper from the what you currency note, because you excite with 365. So we can make n number of this kind of the tagants. There is no special science, but only you have to understanding how this security feature is different from the security feature from the currency. So if you differentiate both, and if you have some solution of that can be suspended in the liquid medium, and that can be slurry, can be easily to mixable with the ethyl cellulose fiber during the paper manufacturing, then you can just to impinge it, and you can make the paper with this kind of the tagant. They can authenticate the paper. So anything more you want to?
Thank you so much, sir. I hope this question is answered. Now we have another message from Ms. Poonam Bhatia, and she's saying, thank you, sir, for interesting and engaging session. Her question is, do these fluorescent material having heavy metals pose any harmful effect to human health?
Already I told you about if you see the activator, the role of activator is very less. I mean, if you host is, I can give the example, like what the mean of the host, activator, and sensitizer. Like suppose you have a class, and all students from the class 10th, and one student is suppose class 11th, right? And one teacher is there, and the question somebody is given to as exam, and this question is come to class 11th. So teacher, then the class 10th student will definitely say like that, this is not belongs to us. Then that question is going to transfer to class 11th. So class 11th student is only one. So he's like an impurity. What energy is going to transfer because of the fact that, because that question belongs to that. So similarly, host is fully based on the non-rare earth waste. It's like D block elements, but only rare earth is doped. That is like very, very small amount. So that kind of the amount cannot be. Even many medicines, we are doping those kind of the rare earths because of the some medicine to manufacture. So there is no harm.
Thank you so much, sir. That was really a wonderful explanation. And now we have another question from Ms. Mamta Patel, and she's asking, what are the legal provisions relating to printing and circulation of forged banknotes?
Pardon? Can you repeat it?
What are the legal provisions relating to printing and circulation of forged banknotes?
False?
Forged.
Okay. So can you repeat it? Because slowly you can just read.
She's asking, what are the legal provisions if somewhere some people are finding these forfeited currency?
Yeah, there is a task force for the anti-counterfeiting. So if they can search out, like most of in India, I can tell you this kind of the feature is not possible to directly to the counterfeit from the Indian any kind of agency, because its investment is very high. So that's why if you see the counterfeiting scenario, it's came from the outside because of the fact that because they have the same machine, they have the same. So establishment of the machines are very, very, very investment. So that's why if you see in India, the counterfeiting sometimes if note is coming, if you know the security feature, definitely you can identify. Like suppose if you understand the color shift, what the angle, where the color is going to change, who can make you fool? If you, I've seen a scenario, I can give an example. Like a person done the color shift the band, they using the packaging paper green, and nicely they just to making the line blue colors on the strip. So if you just to tilt little bit, it's a kind of the illusion. So illusion can be easily identified, but that is not a real counterfeiting. But if you suppose the money is coming from the neighbor countries, I don't want to take the name, but they're more happy to print our currency because they're coming with the visa and they just to travel and they know the series and numbers, even any kind of the feature, and we have the same machine, they can easy to print it. But there is some provision if you do those kind of there's a, even if you do the research, there is a legal provision for the you are doing research. Like when I started the research in 2014, so I first print the Gandhiji on the black paper. But if a person is like they've given a the big letter to me, and they said what you are printing the Gandhiji is the head is not completely smooth, so I am totally hurted. I was totally surprised what I am trying to do and what he want to with me, and he make a complaint and then asked to my director at that time, can you explain, Dr. Gupta, because it come to CPU and you have to answer. So because it's a kind of the people ask like the, so sometimes those kind of the flexibility RTI is just like a waste. So then when it came to us, then I told like that this is a national issue and definitely we have to contribute as a scientific temperament and with the proof and proof of concept is making something, and we want to say at least to this address to the European monopolized companies, we are not full. Now we are making our own indigenous, and definitely one day will come, we will be establish ourselves and our pigment is going to use. So what is the harm to if you can trying to project some area? So then I said to in that letter, one day will come, definitely I will put in the real currency. Don't worry about that. And don't write this kind of the, RTI, because it's not only wasting my time, but also I feel humiliation. So definitely I will again charge against you. So if you do like that and never those kind of the RTI come again. So I can say like that. Sometimes you have required the very bare and bold decision. Although if you see that those kind of things, so there is a provision. So if you're printing even the paper, it's not, you cannot able to get the paper even. So that's why I'm saying if this kind of area, if industry will not really talk to you, many people working in the fluorescence in the last many years in India, I am not just born for the fluorescence. So many people, but if you are not real touch with the technology where you have to utilize, you cannot able to make the pigment or like. So first requirement is to industry should be transparent and they can rely on this. Like I taken the and the student asked that I want to more clarify. Even 2006 myself written a letter to Prime Minister. Make in India, I want to do this. A team has come to NPL and they check the all kind of the fluorescent material. So then they given the MOU and they given the project. So when the letter came from the government side, then my director said like that, this is the summon. You want to still want to work or not? I said I will work. So those kind of the decision you have to take in. If you're not, then you cannot be. So those kind of the provision, once you are working, then automatically the problem is we are escape to reading or like hard work to do ourselves. Once anything you want to achieve, if you are very, very serious about that, no one can, even the God cannot be, come from the universe and they will say, stop you cannot achieve. But
yes, sir, very right,
sir. Should be very good. Otherwise you are just behind the other people's. And I thought already I said, like you can talk about others always. So you set the example, then talk about ourselves.
Yes, sir. So we have another question from Remya R. Nair. And she's asking which technique is used for developing Rephitic nanofibers.
Yeah, we are working on the Rephitic nanofiber by the chemical vapor deposition. So where we are using the ethylene gas, and later on when I done the patent that using the ethylene gas, always I told I have nature to out of the box. So what I thought to ethylene cylinder was very costly. Then I told to that time to my boss to why not we can making the calcium carbide patthar, it's hardly less than 50 rupees, and I can design the reactor that can put the water and put that patthar and you can use the calcium carbide and same gas like producing the acetylene. So if you react with the water, then the C2H2 will be released and the calcium hydroxide going to settle on the bottom. So ultimately we use that and we make the carbon nanofiber. Because I realized this technique nobody use from the calcium carbide to carbon nanofiber. That's why we got the patent granted. Even I saw that patent certificate.
Thank you, sir. Next question is from Mr. Pankaj Kumar. And he's asking which is most suitable material for hydrogen storage for stationery as well as mobile applications.
If you ask to me, if you my question again, I will say like it may be I don't know Ankur will agree or not, but I always out of the box. So no metal hydride will going to work for the real practical application till you can discover double plateau kind of the metal hydride. Double plateau or triple plateau. This journey already started because recently 26th September 2021, I done the MOU with the Hiroshima University. I hope she is the colleague of the Ankur. And I seen some in that group, they are also working for the double plateau. That I thought like that to my boss before he's leave this the earth in 24th April. I talk about the double plateau, and I realized that result shown by some student there. So if you make the double or triple plateau, what the mean of that you understand? Like if you increase the plateau, it means you can increase the capacity of the metal hydride. Otherwise, you have to search something other out of the box. Like I said, the metal hydride based battery, that is the totally hydrogen based battery. You can say like that. Like one side the metal hydride, but hydrogen is like negative electrode. Other side the metal like the Nephron membrane or other membrane, hydrogen will be like positive electrode. This is the my opinion. My dream is the best battery can possible. Only both the agent will be hydrogen. So the beauty is in those kind of the no electrolyte is required, no toxicity will going to involve, and hydrogen will be the even fuel cell is going to very costly. So you can try to protonate on the some multiferroic. So one side multiferroic, they can protonate the hydrogen. Another side the hydride layer that can produce the like negative electrode. So ultimately, just to hydrogen can kind of the recombination and generate the energy. But it's a like kind of the hypothetical. But if you want the real sense and real, so AB5 kind of the material can only work, and because Landian A5 I use in the motorcycle because storage capacity is very less, like less than 2%. So if you want to use the motorcycle, then the drawback was the like 30 to 40 kgs weight for the hydride. So it is very difficult to manage. Either even the iron sheet you can convert it to some carbon composite. Even though metal hydride weight cannot you can reduce because gravimetric and volumetric both capacity required. For the carbon nanostructure, what I done with the PhD, that's because in the work as a PhD work, I can relate to it. Many laboratory work cannot be converted into industry. So if you want to some industry kind of thinking, then you can use the metal hydride. But again, if you suppose store the hydrogen and trying to accelerate it, if you're trying to accelerate it, then you have to discover the injector, because nowadays still even VHU, we are using the liquid injector. So if you properly discover the gas injector, the all story will be very good, because not only not is a big issue, weight percent is less. That can be, people can understand and they will compromise, but the speed, if lightweight, then speed will be less, like 40 km/h. Nobody will want to use two-wheeler or three-wheeler. So if you want to enhance the speed, the key factor was the injector. If you cannot able to accelerate the hydrogen because of the light gas, then it's difficult to come in the picture. So that's why internal combustion is not coming in the picture. But if you see the fuel cell, it's easy to come in the picture because they protonate the hydrogen and trying to use for the application. Although it's a very expensive fuel cell concept, but there is no option, other option. Other option, what I'm saying, you also dream like what I said, you make the hydrogen 2 electrode and trying to third option. So that's why I invite yesterday night to Ankur in 11 o'clock night. So can we again start the journey? Because I have the good confidence in your mechanical department. So I can just you can welcome to, if they can this kind of start the journey, I will be definitely help those guys.
So we have another question, and the question is, for graphitic nanofiber production, can we use the electrospinning technique?
Electrospinning technique is, I didn't understand why you want to two-step technique. When directly you can start the calcium carbide, putting in the water, and you can generate the acetylene gas and directly crack it, and you can make the steel reactor. So you can, if you see my slide carefully, the whole tube was going to nanofibers kind of the structure, fill up with the. if you want to like a spinning technique, first you have to make the Rephitic structure, then it's to dissolve the solution, and then you make the spinning. And if you're doing the spinning, even though, if your aim is to make the paper, then what you are saying is okay. But if your aim is to just to use the carbon nanofiber structure, then you can do the direct CVD.
Yes, sir. Thank you, sir. Now, I guess our convener, Professor Ankur Jain, sir, also has a lot thing to say to you. So I request Ankur, sir, to please join the conversation here. Till the time he's coming, we have another question in the chat box.
Sure.
So this question is, have you seen the practical burning of hydrogen in IC engine?
Yeah, very good question actually. But that can be only able to see by the pyrometer. You cannot do by the naked eye. You can understand because such a high temperature, the burning, the blast impact you cannot see because compression is very high. So you can only presume the piston and the volume distance where we are injecting the gas. Compression ratio you can see it's much higher than the CNG or petrol. If you see, in case of the petrol, it's 1:3, CNG 1:8. Because when you're trying to liquid fuel, then the ratio is very less. When you try to hydrogen, 1:33, it's very high. So compress the hydrogen is not an easy job. And you are saying the real time picturization or naked eye to see, it's very difficult because inside the chamber it's happened. But if you put some pyrometer sensor, definitely you can realize the temperature as well. That's why we design the catalyst, right? How we can know the catalyst that can be protect those kind of the chamber, because we know which kind of the coating we have required. So according to temperature, we are coated there. So if further they have any query, then I can be.
Yes, sir. I guess we have another question. Can you show some example of top-down method and bottom-up method to grow a nanostructure? I guess that is a very fundamental question.
On in my morning slide, if you remember, I shown a lithographic technique like FIB or iron beam, and we make the pattern like guitar or like the flower or like CSIR-NPL. So that is the technique is say the bottom up, right? You start from the bulk and coming up with the nano. When you talk about the top down, then in that case you can nucleate something from the molecule or nucleate the structure and come up to some molecule of the nano. So that is the bottom up, and top down is the machining effect. Like first one is the top down and second one is the bottom up. Like one case, the bulk structure, you are trying to write something with the nano by the machining effect like FIB or electron beam. Other cases, you can nucleate and trying to grow some like nanostructure like nanorod or quantum dot or nanotube. So that is the bottom up.
With this, sir, our questions are ended, and now I invite our convener, Professor Ankur Jain, sir, to please join the session.
Thanks, Dr. Kriti. Thank you, Dr. Bipin. It was really a nice session. Both the sessions actually were very interesting, and I hope participants must have enjoyed it. So definitely with your idea, we will go ahead. As we discussed last night also, I will definitely visit you soon, and let us move forward.
Sure. So can I just to leave the platform because I have to take the lunch and back to lab. Any further no question, then I can, or I please if any question just read.
Yeah, I think that should be enough for today. Let us close the session.
Yeah, sure.
Thank you. Thank you
so
once
can
again.
I leave now, Ankur?
Yeah, definitely. Yeah,
yeah,
thanks.